Muon? Anybody heard of muons? This is part of it. It's really fun stuff. Stanford, they came up with this. A muon should not be able to be detected on the face of the Earth because as soon as it hits the atmosphere, it's created from a collision and muon, and it should disappear, right? Before it hits here because it's so short-lived. But in relativistic reasoning, that muon is in its own space-time thing. It can go through the Earth. So they were detecting, this is what proves that theory stuff works. They can detect muons on the surface of the Earth, even down in the canyons, where they should not exist. But because Einstein's thing that shows space-time, it's in its space-time. It'll do. Anyway, we're back to where we are now. Anybody know what our quarks are? These are all high energy. These are the ones you hear that decay. This is back when the Big Bang, so to speak, expansion was still compacted and hotter. That's when these existed. They still make them out there. My friend Leon Letterman out of the Chicago one, not Oregon, it's Fermi Lab. He got credit for the top. Third generation, second generation. Now when it's cool, the first generation of quarks is what makes up all the matter that's here. What are the quarks? Up and down. What's bigger, an up or down? I'll tell you, down. And what is our force carrier? See, you know them. I'm just nervous on the electron. In another world, where charm and strange take the place of up and downs, muon's the force carrier. And the real high energy, hot stuff, top bottoms in the tau. But for us, up, down, electron. Okay? Anybody know what the quark combination for a proton is? See, this is a great lesson because watch what you get to do. You get to teach fractions in a way that the kids are going to get it. Murray-Gell-Mann, again, proposed fractional electromagnetic charges. Everything's plus or negative, right? Not in the quark world, and this has been proven now. It's not science fiction anymore. I'll tell you, 2 ups and a down. That's a proton. So what I pictured, Big Bang is an expansion, is what that Big Bang thing is. Don't let that word trick you or anything, okay? Everything was condensed, hotter, all that, expands, cools. All the hydrogen that was out there, remember I said now gravity pulls it together. At 15 million degrees, you can start fusion. This is what our first generation stars did, what our sun is still doing. 2 protons come together at 15 million degrees. What do you think it does? Makes a neutron. We know that, right? So what do you think a neutron is? 2 ups and a down is the proton. A neutron is 2 downs and an up. So again, with my artistic mind, not that I'm an artist, but I'm jealous of artists who are, I can't even draw flies. Neutron, you still have the proton. This is why it's called deuterium. Up, down, okay? This is the first reaction in the sun, in the core. That's why it's got to be in there where it's more compact and dense. There's gluons that hold these 3 together for the proton. And then the neutrons, quarks, are held by another 3 quarks. I should be doing this on the whiteboard in color. So I'm looking at this and I'm like, that looks like, some say a cat if I draw the ears bigger. So I call it the neutron bunny. And kids, I've done this with 8-year-olds at the space camp. Like I said, before I let them play with space toys, they had to do this. And they would, and they're like, is it Jimmy Neutron's bunny? You know what I mean? I'm like, great, way to go, kid. So, the balance equation, if you're interested, I know this is beyond a lot of you, but if you learn stuff and get exposed to this, it'll give you confidence when you do read stuff.
Randy, colored pens are over there for the whiteboard.
Yeah, I know there was one color missing, that's why I didn't start messing with it. So the balance equation here, an up to become a down gives that antimatter. The only way you can add the mass is to take away mass. That's where that positron comes in. This happens in our sun, the first reaction. How many people talk about this? Why do you think I sleep in my truck on the way to drive up here instead of getting put up at the Hilton for my talk? Nobody knows this. Nobody really wants to. What I've thrown at you has taken me years to take from one book and another and put it together and go, look how simple it is. And if you can draw it with something an 8-year-old can do. So that's my goal. This is what I'm getting to now. The hydrogen, because this is all fundamental, everything we're taught, but then we don't use it. Fundamentally, the temperature of the sun, from Einstein's E equals what? Have you ever used that equation in anything? Yeah. This is where 15 million degrees for the sun, that's a constant, mass. The energy of that fusing together can make mass. And the only way it does it is by pair production. This is what SLAC is famous for. Whenever we make matter, we make the same amount of antimatter. And that's one of the cosmologists' thing now is where's all the antimatter? Because everything now is ups and down quarks that make all this. Where's the antimatter? Because everything's made in pairs whenever we do it. But where's all the other antimatter? That's what you'll, every year in Astronomy magazine, you'll see a whole thing devoted to that. And you'll read it and you'll go, I think I learned something. I don't know. And even the quark thing, they throw them in the boxes. This is my beef. We know the neutron is bigger than the proton, right? So 2 downs and an up, and 2 ups and a down. So when a kid looks at that, what's bigger, proton or a neutron? The neutron. Now when you see this chart here, what's bigger, an up quark or a down quark? You just look at neutron bunny here, right? He's glue on whiskers. What's bigger, an up or a down? I should draw that bigger, shouldn't I? What's bigger, an up or a down? Here's, I love you guys out of Berkeley. You can get these posters free and stuff. You seen them? The show Big Bang is on TV. In the commercial, they had that up on the wall there. If you look at the box of their quarks, they're letters. This is something the typologist does. You know, the typesetter. They're all the same size. So when I did this, I'm like, well, if an up quark is bigger than a down, see, they're like letters. The energies are telling you what the size is also. So I'm looking at this stuff critically. I don't trust these guys. They make their living, and they stay at the hill when they go to those conferences. And I go and present papers to them, and where are they? They're out sightseeing. They're not there to learn anything, you know? So this right there, when you see it drawn bigger, neutron bigger. My point is, I want you to know how make elements. The helium alpha particle, they call the 4 mass 2 He, right? Another proton, we'll just put it in there. What comes after, now that we all know hydrogen, I won't go into the neutrinos, the antineutrinos and stuff there. Hydrogen makes heat in the sun. What's made next? Very good. Because see, that's where I was saying, I have a degree in chemistry and I didn't know where the heck carbon comes from. Seriously. And I'm like, that's criminal. How am I, 1, supposed to think I learned anything, and 2, related to anybody? I don't know where carbon comes from. So I got these beautiful little goddaughters in Kentucky, and the Cincinnati Reds, my team, whenever I hear like Ken Griffey, Cincinnati Red Star, the Red Star. Red stars make carbon. Now what do the astronomers out there say? Oh, red stars are cool, aren't they? They're not as hot as blue, right? Well, what are you seeing? You're seeing the atmosphere of a red star. Have you ever heard of Betelgeuse? Do you know how big that radius is? For a star. The atmosphere of Betelgeuse is out where Jupiter is. And it's a red star. You think it's cool? You think it's a cool because it's red? It's not hot as a blue one? We're only seeing the atmosphere. Inside a red supergiant is where 3 heliums have to be fused together. This is why you need this chart of the nuclides to learn how elements are made. And learning history is how I learned this. Hans Bethe, did you ever hear him? It's spelled B-E-T-H-E. I sent him 2 glow-in-the-dark stars when he was 89 years old back in Cornell in the mail. It was white.